Hi, I'm Scott Hanselman. This is another episode of Hanselman. Today I'm chatting with Matthew Shapiro. In his day job, he's a staff video architect at Game Changer, but at night, he's making insane things on GitHub, which is why I'm having him here today. How are you, sir?
I am great.
Thanks for hanging out. So you had a great week last week, didn't you?
The amount of excitement I've seen from that Reddit post that I posted of the Mario platform has been incredible.
Yeah. So you went and you threw out something on Reddit and you say, "Hey, everybody, in my copious spare time while working and raising kids, I was messing around and I put together a library that pulled some other libraries together. And you have a thing that lets you use C# to make ROMs for the Super Nintendo. And then you also run Hacker News for a time, at the top spot."
For a day I was pretty on the front page, which was incredible. I didn't even post it there; somebody else did, and I found it by accident.
Yeah. So now suddenly, this is one of those things that happens when you kind of go tiny viral. Is that some project you did in your spare time is now being watched, and people want more, and now you have to quit your job and work full time on Super Nintendo ROMs, right?
I would love that. But well, it's funny because I do a lot of random stuff throughout the years, and I have a small group of engineers that are friends, and I always get comments of "huh, that's neat," and sometimes I'll post something and I'll get some "huh, that's neat," and that's about it. And this is the first time I actually got somebody. So I actually got one person who's so excited that he started contributing to the main project, and I was like, "Whoa, this is a weird feeling."
That's cool. So you've got a contributor now, which is great. This is how open source starts, right? You do things, you throw spaghetti against the wall, and then one day it sticks, and then you have a little community of people who are excited about the thing you're excited about.
And then you have freak out about people looking at code that you wrote in your hobby time.
That is the real crisis. So help me understand though how this started, because we know that there's a bunch of enthusiasts even now in 2025 excited about Nintendo and Super Nintendo. We've got tons of documentation. It has never been a better time, I would say, to be doing retro gaming and retro games than it is now, right?
Right. So this actually didn't start specifically with the goal of Super Nintendo in mind or any console gaming at all. The very short story is that one of my good friends, Justin Johnson at Mojang, knew that I was going on parental leave because my daughter was about to be born, and he's like, "Hey, I have a meadow, a Wilderness Labs meadow. I have a little retro game engine on it, and I need help optimizing it." And he's like, "You got a lot of free time coming up because of your parental leave. How about what if you do it?" And so he got me a bunch of the equipment, and I just became enthralled with mostly embedded development. And so I did a lot of optimizations, and I got that to a good place. And then I started working on. I got it as far as I could go with IO constraints was what was bottlenecking me. And so, a long story short is I wrote a small little GPU for microprocessors that runs on a ESP32, but that's all C code. And I came into a fork of the road of I want to be able to write more C#. I can do most languages, but I love C#. And so I started theory crafting on, well, what actually would it take to run C# on other devices? And it's not feasible for the .NET team to create AOT for all the different platforms that nobody's going to use. It's also not feasible for me in my free time to learn assembly for every single platform and start doing it myself. And so I started realizing, have you ever heard of a programming language called NIM?
NIM, yeah, sure.
Yeah. Well, I thought about it and I played with it before, and one of the things that it does is it doesn't compile down to LLVM IR, it compiles down to C. And so that allows it to run anywhere. And so as long as you have a C compiler, then you can run your NIM code anywhere. And then I started thinking, well, what if you actually take MSIL and start and actually translate that to C? And I started playing around with the idea, and it started working. And so it just took off. One of the So I started off without an actual goal in mind of like, let me see if I can do this, just as like a just an idea in my head, just as a challenge. And then the whole CrowdStrike issue thing appeared. The whole CrowdStrike issue appeared. Well, it was crashing on the machines, and one of the reasons that doesn't necessarily happen as badly on the Linux side and soon to be on the Windows side is because of eBPF. Have you heard of that?
Okay. This is keeping the kernel separated, right?
Yeah. So it allows you to. So eBPF works by you compile special programs down into a special bytecode that the kernel can verify that it can't crash, it can't allocate memory, it can't stall, and
Right.
it has various checks and balances in it.
Right. This is basically, it's called the extended Berkeley packet filter, and it's a way of running sandboxed programs without modifying the kernel source code. It's making little cages for your code to run inside the kernel.
Right, exactly. And that was a perfect, and it's great because you can add a lot of observability into Linux kernels without actually without risking nuking anything or doing anything poorly. And then you have a user space component that talks back and forth of it that does the user space act.
It's a clean separation of concerns.
Exactly. And that's why Windows, I think, is moving towards that model now, especially after the CrowdStrike. And I was just thinking, eBPF has no, at this point, the eBPF applications do not have memory allocation. So it's a perfect use case for where my transpiler was at that time. And so I was able to, and if you can imagine having C# running both the user space and the kernel space at the same time, that got really compelling. And so I got proof of concepts going, and that actually works. So you can actually write Linux eBPF programs in C# and have them run inside the Linux kernel.
That's cool. I think the .NET team will be excited about that because there's all this talk about using Rust to run things in the Linux kernel.
Right. And yeah, and because we're going down the C, we can just reuse all the normal C tool chains that everything relies on. So I got that working, and it was actually like I did a Reddit post for that, and I got some of the neat responses I got, but wasn't nearly as much as this. And so because this is all my hobby, I was trying to figure out what to do next to move it forward. And one of my friends, Lawrence Welpton, who works at Microsoft, mentioned that he's like, what about making SNES games? And I was like, no, I don't know if that's going to be possible because I didn't think that there was a C toolchain for it. I thought most SNES games and Super Nintendo games were written in pure assembly, right? But it turns out that there was a C library and SDK for making Super Nintendo games in C, and it's actually fairly active. And once I saw that, it fit the bill perfectly because there's no memory there's no dynamic memory allocation. And so I just went to town trying to get that to work. And it makes you really appreciate modern debugging tools when things don't go right.
Yeah. It makes you wonder, like there's still people now, even in modern times, that are very famous people, like Brendan Burns, who works on Kubernetes, like famously doesn't like debuggers. He's just all about got here debugging.
Yeah.
And the kinds of debugging that we would do 30 years ago with like soft ice or whatever, it was basically like stop and stare at a bunch of registers and hope for the best, or a bunch of console.write lines.
Yeah, there was some points where I was in a emulator that's very much designed for debugging SNES games and going through assembly that I was looking up ad hoc on demand to try and figure out why some examples weren't working. And it turned out I just mistyped some things. But that ends up costing you like hours.
Yeah. So help me understand the stack, because we know that a Super Nintendo is everyone wrote those games in assembler, correct? Right. At the time. And right. With these, what was the processor in a Super Nintendo? Was it a 6502 or was it a 68,000?
I think it's a modified 6502. I think it had some changes to it.
Let me think here. Oh, here we go. It's a 65816 which is a 16-bit CPU, a fully fledged. It's not a fully fledged 68,000, but it has a 6502 compatibility mode, so you can do both. And that was the magic. It was a bridge to the future.
Right.
So you've got 65 C816 for 6502 developers. Interesting. Okay, so these ROMs are well understood. The emulators are well understood, and you wanted to go from C# all the way into targeting the specific processor, and you didn't go straight there. You bounced around. You went MSIL to C, and then from C to assembly, and then assembly. Like, walk me through the hello world process.
So the hello world is essentially creating a C# program it's creating a C# program that's fairly standard, right? There's some caveats, like right now I don't support reference types because I haven't implemented garbage collection yet, and that's kind of on my next task. Although you wouldn't use garbage collection or reference counting, or really any of that style of programming for an SNES because it's too much overhead. And there's no dynamic memory allocation on a SNES, really. So you start with a C# program, and you run it through a program that I call DNTC, which is my .NET to C transpiler. And that actually goes through, and you give it a root function of what function you want to start the transpilation process at, and it sort of creates a dependency graph of your whole, all the types involved, all the functions that get called, everything that it needs, and it makes sure everything that gets called, it has a solution for. And then one by one, it starts taking the IL and converting it into a syntax tree that it then converts into C statements as it reads the IL one bit at a time. It's a fairly interesting process because the .NET bytecode is very much it's very much made specifically as a stack machine that and it's designed as it's a stack machine that it's evaluating at runtime. And I have a huge appreciation for the .NET JIT team now, because trying to take that stack machine and figuring out optimizations of how to do that ahead of time is really fascinating.
Yeah. It's hard. There's a lot going on. And I think that people who are even in the regular .NET community who aren't building things for a Super Nintendo don't really understand how deep the possibilities are, the combinatorics, because the jitter right now says, oh, you're on x86, oh, you're on x64, oh, you're on ARM, and then looks at specific processor instructions. It says, oh, you're on x64, but you're on an older Intel, or you're on a newer Intel, and makes all kinds of decisions at the jitter level. So then you have this Cartesian product of all the different operating systems, all the different processors, all the different flavors within sub flavors and subversions of processors. It gets complicated. And then if you wanted to apply AOT to that, things get really, really hairy.
Well, especially if you think about some optimizations that the C# compiler itself does. So if you're just doing a simple swap of two variables, you have A, you have B, and you want to swap the values. Even if you use temporary variables, the C# compiler will optimize it into just put A's value on the stack, put B's value on the stack, and then just pop them in the opposite order into the alternate variables. But you can't do that ahead of time. You can't do that. Like, that doesn't work ahead of time. And especially with the transpiler, I have to know exactly what it's targeting. And so you actually have to jump through some hoops to be able to resolve that, recognize that situation is going to occur, and then resolve it into assembly language or C that actually does the correct behavior that you're expecting.
My goodness. So you're taking any language that can compile to MSIL, to intermediate language, presumably C# primarily, and you compile it into C source code, specifically C99, that flavor of C. Is that correct?
Yeah. So the intention was C99, but there's a lot of so the idea right now is that you take you build a transpiler, you can build transpiler plugin to change things up a bit. And that's needed because the C library that targets SNES isn't C99 compliant. And so there are some features like zeroing out globals that are not actually supported, that you then have to like customize the transpilation operations to handle. It tries to be C99 compliant, but there's the customization and flexibility to be able to target anything, any C compiler really.
Mm-hmm. And one of the things that I think you do really cool, and I want to understand if it's part of your this DNTC, the .NET to C transpiler, is you have these attributes like native function call or native global or custom function name, because you're basically kind of taking extern C to the next level and basically letting C# and this transpiler almost work in both directions. You're really giving hints on how the C code should end up and what the results are. And it feels like this is an oversimplification, but P invoke, right? Platform invoke is the ability of C# to go and call into extern Cs, into Cs that are sitting around in random libraries, whether it be a shared object in Linux or a DLL in Windows. But if you're on the way downstairs anyway, you apply these attributes and then they find their way all the way down, and you basically set up your calling conventions for success with these attributes.
Yeah, so one of the core principle, I guess, pillars that I built this transpiler on is that it should be easy not only to create a C# application that references C code. Like the SNES example is, you can kind of think of it as a C# program that's calling into native C functions for the SDK.
Yeah.
But there's also the reverse that I wanted to make sure was a first-class citizen of. You can take C# code and integrate it into your existing C application, or as long as you have C headers. And so there's a lot of these customizations and attributes that you can add to really customize how things are done. Like for the SNES ROM, it's specifically looking for a function called main with a lowercase m and all those things. And so you need to be able to tell the transpiler, hey, tweak this name a bit so that it fits. And with the SNES ROMs, you actually have labels in the assembly. You have labels in the assembly files that actually target memory locations, and so you need to be able to call those with the exact names. So there's a lot of examples of that.
Well, I can look at an example here. I'm looking at your game, public static class game.
Yeah.
And you've got a main, public static int main. And then you made sure that it's main. You said custom function name, lowercase main. Yeah. And then you've got some things like tile font or pal font. And these are little static bytes where things need to show up.
Right.
And then if you go over into like data.asm, which is the assembly language kind of like resource that's along for the ride, there it is. Tile font, pal font. So it's this, you're creating this chain of responsibility to make sure that everything lines up when it all happens at the last minute.
Yeah. And it makes sure there's no disconnections when you are actually calling a native function. Like you said, like a native P invoke. And it makes it zero cost to actually convert to actually call native functions, because there's no actual. It's all linked together in the final binary. It's not actually doing a shared library.
Now, this is not idiomatic. I'm looking at this and I see using .NET/SNES core and namespace, and that all feels good. And I see some attributes, and that's cool. And then it looks like it's mostly static functions hanging off of helpers, like SNES console, set the text, or background.set graphics pointer.
Yeah.
But it still also feels high level. So it's funny. You feel high level, but you really aren't.
So the Mario platformer example was very much a almost line by line conversion that I did from the C example to it. Mm-hmm. There are ways that there are ideas that I have to make it a bit more idiomatic C#. Like, so for example, one part of that code passes around function pointers, or it passes on delegates, which gets transpiled down to function pointers.
Mm-hmm.
But I want to be able to use static interface members to replace that, for example.
Mm-hmm.
There's a lot of opportunities there. The breakout example is a better example of where there's a bit more idiomatic. Well, I've taken a bit more time to make the example a bit more idiomatic. The Mario one was mostly just let me make sure that everything works end to end. before I start messing.
Right. There's something new from our sponsor, Text Control. For decades, TX Text Control's rendering was tied to Windows functionality. But now it's a new era. TX Text Control is platform independent. You can run your .NET applications on Windows or Linux, deploy with Docker containers, Kubernetes, or host directly in Azure App Services. Seamlessly integrate document editing, signing, collaboration, and PDF processing into your ASP.NET Core and Angular applications. Are you ready to see it in action? Check out the live demo at demos.textcontrol.com. That's demos.textcontrol.com. Now, this is all sitting on top of a thing called PVS NES Lib, or PV-SNES Lib,
Right.
made by a gentleman named Alec out of France. That's a library that's been around for 3 or 4 years, that I think that they started from an SDK called the SNES SDK over on Google Code by a gentleman named Ulrich Hecht. So this is 10 or 15 years of people trying to get C
Right.
programming available for Super Nintendo. So this gentleman, Alec, is sitting on top of the shoulders of this other gentleman named Ulrich, and on and as well as a community and lots of different things. How did you know this would all line up, though? How do you pick a library and you say, yeah, I'm going to stand on that, and I think it'll support me?
That's the whole thing of like everything I do. I'm just standing on the shoulder of what people have done before. So even just like the IL functionality, like I wouldn't be able to do any. This would be hard. And if I targeted C# for the transpilation, that would be. I could use a Roslyn, but that would be hard because C# kind of a moving target, and I'd have to keep that updated. But the MSIL is a good base, but I wouldn't. But I wouldn't want to write the whole library to actually interpret all the MSIL code itself. But the Mono project, I think Mono.Cesar is I don't know if Mono.Cesar is an official project or not.
I think it is. I mean, certainly the world is sitting on top of Cecil, so yeah, I think it's pretty important.
Yeah, so like without Cecil, without PVS NES, I wouldn't have been able to do it. And really, the only reason I was even able to do the eBPF stuff functionality is because all of the work that went into the C libraries to unlock all of that capabilities.
Mm-hmm.
So it's always fascinating when I take a step back and look at like everything that I'm like, what made everything I'm doing possible.
Yeah, it's overwhelming. The stack is so deep now. I think it's funny when people call themselves full stack developers, but they don't realize how many shoulders they're standing on top of over so much time, because this is about the most documented piece of hardware on the planet at this point. And watching the emulators, I think, is super fun, because it's not just emulating a ROM. You can actually have emulators that will show what's happening in real time in the memory of the Super Nintendo. So it's a really great way to learn computer science.
Yeah, there were several bugs that I was going through during the SNES process where I was trying to I was looking at all the stack registers on the SNES. I was looking at memory locations. I was looking at tile sets, trying to figure out why something wasn't appearing on the screen when I figured it should. And it's fascinating to go down. Like this whole trip has made me really want to. I actually bought an x86 assembly book just to start like understanding that part of the stack a bit more. Just how everything works. And this has also made me want to go to start playing with FPGAs and playing around with a lot of the digital logic that entails.
Yeah, I bought recently, where is it here? I think it was called an Ice Stick FPGA, and it just plugs directly into your USB. And it's, I don't know if it would be big enough to do something like that, but if you think about some of the really cool work that's happening on these programmable gated arrays, these FPGA systems like the Analog Pocket, which I think is truly one of the most extraordinary pieces of hardware that's just happened, along with the MiSTer, MiSTER, to allow someone to effectively transform dynamically a piece of hardware into another piece of hardware and then run the original code on it with these cores is amazing.
Yeah, and once you start playing with those and you start realizing what those are doing, and you start learning, because I started going through NAND Game, a website called NAND Game, which takes you all the way from a NAND gate all the way to a very basic pot CPU. and memory unit. A very basic computer, essentially.
Well, there's also NAND to Tetris.
Yeah, there's NAND to Tetris. There's also a game, I'm blanking on the name, on Steam. There's also a couple of things on Steam that do that. And it's when you start realizing how... I really want to put a presentation together at one point for work, but like the abstractions that make up a CPU is just fascinating. It's not even just like the implementation details of how each step, it's how all the abstractions work together to get to that point.
I feel like at some point I need to quit my job just to do these projects in my spare time.
Yeah.
You know?
Oh, yeah. It's especially now that I have kids, it's extremely difficult with my 1 hour free time at night.
There's a buddy of mine who's got a website called Pikuma, Pikuma. You love that guy?
So I love that guy. And so the next step for my project is I actually bought his PlayStation 1 course. And I actually want to get reference types working and start working on a very basic PS1 C# game engine.
Yeah. I had, that's Gustavo Pezzi.
Yes.
He is fantastic. He was on the show a while back, and he, for folks that are listening, has a Nintendo programming with assembly course, Atari programming with assembly. He's even got a really great course, which I think is really the best one he's got, which is his ray casting engine with C. So he basically write Castle Wolfenstein from C from scratch.
I found his course from the 3D graphics from scratch, 3D rendering from scratch course. That's how I started with him. Yeah.
Yeah. So I was able to get this working really easily. I just went to your GitHub, which is KALLDREXX. We'll have a link in the show notes. And I just did a git clone, although you do need two things. You have to do a git submodule update init recursive, because you pull in two specific, you've actually pinned down to a commit two specific submodules. One is the PVS SNES, and then one is your own DNTC. And then you have to use SSH keys. You can't do this with the standard way of logging in. So if folks are listening and they're not super familiar with how to do this, the easiest way is to get the GitHub CLI, and then you say GHAuth login, and it'll actually create the SSH keys for you. And I was able to get this running inside of WSL, the Windows Subsystem for Linux, in just about 10 minutes. And then I picked up a free Super Nintendo emulator and then just ran Make. It was amazing. It just worked. It was just 10 minutes end to end.
Yeah, I've never done a lot of Makefile stuff before this project. And that was...
You're kidding. I was going to compliment you on your use of Makefiles. And I said, this person's a Makefile expert, because you had Makefile defaults, Makefile base. And I was actually running around relearning how Makefiles do their dependency tree.
No, I had a very basic one set up, and I'm like, this is going to be a pain for anyone who wants to start a new project or based off of. And so I just tried to figure out how to actually... I just brute forced my way until I came up with something somewhat sane.
Well, I thought it worked out really great, because you didn't try to make it fight with .NET Build.
Right.
You cleaned it up nice and simple, because you have a lot of other things that people don't realize when you're putting together a Super Nintendo, and that's assets, tiles, bitmaps, fonts or bitmaps, sprites. It kind of goes on and on and on. As we get towards the end here, I know that people will go and check out all of these samples, Hello World, the Mario one, and then the more advanced one, which you want to check out, which is the Breakout one. But just understanding the Mario one for a second, there's the Mario long PNG that represents his first level. How does he know what to jump on versus what's a pixel versus what's he allowed to touch?
Well, what's interesting, it's the PVS SNES lib SDK is kind of interesting in that regard, in that it uses tiled to create the tile map. So it allows you to use a modern tool to make your C# to make your maps. And so it has you can actually set collisions based on the tile types that you're mapping out in the tiled program, and the SDK is automatically set up to convert those. And so it's not the PVSNES lib isn't necessarily a SNES generic SDK. It's it has some opinions about how objects should react, how sprites should react, how maps react, and so it has built-in collision detection and built-in entities for functionality. So it makes it really easy to actually do that with somewhat modern tools. If you ever watch those interviews,
that's a really nice way to think about it.
If you ever watch those interviews, like those old things with Miyamoto, where they'll show how they actually made Super Mario Brothers. They actually had like good paper, and they're actually marking out different blocks and how to do it, and then the programmer would have to go in and manually enter all those bytes in.
That's funny that you mentioned that, because if you poke around inside of your Mario example, you've got a couple of, ASMX files. And then I just dropped into one of the map files, which was a TMJ, and it's just a big old JSON filled with bytes that go on for forever and ever and ever and ever. But it's also cool that we've got PNGs in there, which is a modern graphics format. And we've got Mario's jump sound as a modern WAV file. So it is this wonderful amalgamation of things that didn't exist at the time that the SNES was created, and things that exist now. Why not take advantage of those modern bits of comfort?
Yeah, and some of the things that the modern community there is actually doing, the games that they're actually making at the PVSNES lib Discord is pretty incredible.
Yeah, this is a great way to jump into the community. You're standing on top of them, and they're standing on top of others, and everyone is just having fun putting these things together. You can get all of this running really, really easily. I think it's worth taking 20 minutes. It's also a testament to Windows and the WSL on how easy it was. I dropped into WSL. I did the make once I had done a couple of apt updates and installed some basic makefile things. And then I typed explorer.exe, which then opened Explorer inside of WSL, and I dragged the newly created Mario game directly into my the surface of my Windows emulator. And now I'm going to go and check out the Breakout game as well that you've got working.
And we actually have, the video. I have a video on my LinkedIn. Somebody actually took the Breakout game, and actually it was running on real SNES hardware.
Oh wow! So they dumped it somehow into the
they put game. It on a flat. They were able to put it on a flash cart and run it on a real Super Nintendo.
Oh man, that's so cool! I'll include a link to that in the show notes, so we'll be able to see that. I see on your LinkedIn right now. Fantastic! What fun you're having in your hour of free time each night, Matt.
It's I
this is so good.
I can't actually have small projects. My brain doesn't let me do small projects. It's always big projects that nag me for months on end.
There's nothing wrong with that. Not if those small projects allow me to write C# on in modern day C# on a Super Nintendo. I think that's worth it. So I appreciate your service, and certainly those that whose shoulders we stand on top of. Thank you so much, Matthew Shapiro, for hanging out with me today.
Thank you for having me. It's been a pleasure.
This has been another episode of Hanselman, and we'll see you again next week.